Hey everyone, in this video we're going to learn a different way to solve quadratic equations, and this is called the square root method. We use this method when there is only one term with x in it, just like the last part of our word problem from our previous video. Remember that when we solve a quadratic equation, we are looking for the x-intercepts of the function. Where does the graph cross the x-axis? You remember SADMAP? It's the acronym that we use for reverse order of operations, where the S stands for subtraction and the A for addition, and these are done in order. The D is for division and the M is for multiplication. Those are also done in order. Exponents, which in our case is going to be a 2, is going to be a big factor in solving these equations. Gets evaluated after any division and multiplication. And finally, we take care of anything that's in parentheses. Remember that addition and subtraction are inverse operations. They undo each other. Multiplication and division are inverse operations. They also undo each other. And our newest inverse operations are squaring and square rooting. If I take the square root of a number that is already squared, the square root symbol and the square cancel each other out, and that leaves me with just the number that was under the radical. So a couple of important things when we're dealing with square roots. Every positive number has two square roots, a positive one and a negative one. If I want to know what number times itself equals 25, all I have to do is take the square root of both sides. Now I know that the square root of 25 is 5, but if I didn't know that, I could come on over to my calculator to find the square root. To do that, you're going to hit the yellow button, that second button, and then hit x squared. The square root symbol is right above the x squared in yellow because it's an inverse operation. So I can take the square root of 25 and I end up with 5. The calculator is not going to give you the negative version, but square roots are the numbers that when you multiply them by themselves, they give you their square. So I know that 5 times 5 is 25. But isn't negative 5 times negative 5 also 25? So this equation actually has two solutions. They're x equals 5 and x equals negative 5. If I go to take the square root of 29, I don't think that's on my square root list. So I'm going to see what it is in the calculator. So I hit second, x squared. I type in my 29. Oh, I get a really long decimal. Don't freak out, it's okay. We can just write our answer as the square root of 29. But it's not just the positive square root of 29. There's also the negative square root of 29. So when you're taking the square root of a positive number, remember that there are two answers. And we're working with a quadratic. So unless that number was actually the vertex, we're going to end up with two answers. Every negative number has no square roots. If I go to take the square root of negative 25, well, that's negative 5. But it's not, Because what's negative 5 times negative 5? It's positive 25. And it's not 5 either, because 5 times 5 is also positive 25. So neither of those things work. So let's see what the calculator says. If I take the square root of negative 25, error, non-real ands. What that means is that there is no real solution. There is no tangible number. There is no number that you guys have ever worked with that I can square and make negative 25. So the moment that you realize you have to take the square root of a negative number, you know that there are no real solutions. And you can stop right there. In example B, we have to do a little more work. The invisible number in front of x squared is actually negative 1. So in order to get my square alone, I have to divide by a negative 1. So x squared actually equals negative 29. But when I go to take the square root, I'm taking the square root of a negative number. No real solutions. And you can stop your problem right there. So, I want to solve these quadratic equations. In order to solve a quadratic equation that only has one term with x in it, all I have to do is apply those same solving equation rules that you guys have been working with since elementary school. Draw your dividing line. Maybe you write your acronym for the order of operations, SADMAP, and work through them in order. In letter A, there is a subtraction. I need to undo it with addition. X squared equals 81. And then I go to take the square root of both sides. That is the inverse operation of squaring. And when I do that, I get x equals 9. But I also get x equals negative 9. So this quadratic has two x-intercepts, one at positive 9 and one at negative 9. In letter B, I have a similar situation. It's a two-step. But instead of adding to eliminate, I have to start with subtraction because I've got a positive 4 that I need to move to the other side. M squared equals 2. I don't know what the square root of 2 is. So I come over to my calculator. I hit second mode to quit out of the screen that I was in. I hit second square root. I plug my 2 in. I get that crazy decimal. So I take the square root of both sides. My answers are positive square root of 2 and negative square root of 2. So my quadratic for this question crosses the x-intercept somewhere between 1 and 2, both on the positive side and on the negative side. All right, a little more complicated. I want to solve this quadratic equation, so I'm going to draw my dividing line. I write my SADMAP. Is there any addition or subtraction that occurs outside of parentheses? And the answer is yes. I've got this plus 9 here. So to get rid of it, I'm going to subtract 9 from both sides. 10x squared equals 490. So I've taken care of the addition and subtraction. Now I look and I see that I actually have some multiplication going on. 10 is multiplying x squared. So I'm going to divide both sides by positive 10. you are welcome to use the calculator to do that. But dividing by 10 when there's zeros is easy because the zeros just cancel out. And I'm left with x squared equals 49. And then I go to take the square root of both sides, and 49 seems kind of familiar, but I'm not sure. So I'm going to take the square root of 49 in the calculator, and hey, I get a nice easy whole number. That's right, 7 times 7 is 49. But so is negative 7 times negative 7. So my two x-intercepts are x equals 7 and x equals negative 7. Whoa, letter B's got parentheses in it. That's all right. I'm going to go back to my SADMAP. And I look, do I have any addition or subtraction? And I do. I've got two of them. I've got one here and one here. But only the minus 6 is outside of parentheses. I can't mess with that x minus 4 inside because that's inside parentheses and that comes last. So I'm going to cancel out this 6 by adding 6 to both sides. And I'm left with 2 times x minus 4 squared equals 72. So I've taken care of the addition and subtraction. I also have a times 2 outside of parentheses. So I'm going to divide both sides by 2. And I'm left with x minus 4 squared equals 36. Because that's what 72 divided by 2 is. And here's where people end up doing things a little tricky. Exponents comes before parentheses. And since all of x minus 4 is being squared, my next step is to take the square root. So then I have x minus 4 equals 6. But I also have x minus 4 equals negative 6. So right here, I've got two equations to solve, 1 and 2. The moment you take the square root in an equation, you actually split into two pieces. So the first one, to get x alone, I add 4, and I get x equals 10. But then I also have to add 4 to negative 6. And x equals negative 2. So this equation has two x-intercepts, one at positive 10 and one at negative 2. All right? So, hopefully you're feeling okay. If not, you can always ask me questions. Now it's your turn to try. Solve each of the following equations using the square root method. Make sure to get your answers checked before moving on. Remember, we use the square root method when we only have one term with x in it. All right? So now you've made it through two methods, solving by factoring and square roots.